Hey you guys, this is Joseph again. This should be our last video. We only have like 3 or 4 more slides to cover. We're just going to be talking about geothermal plants and what they look like. This is typically what you'll see in a geothermal plant right here. It doesn't look like a whole lot, but it's just pipes in the ground. This is steam coming off the top, some steam, and then this is probably a bleeder valve, something like that. But it's relatively underground in nature. You do get it you'd normally have a rather large processing facility. These are cooler towers, same thing right there, to harness that energy. Trends in geothermal energy generation. Indonesia has the highest growth versus 2000, if you want to look at that slope. Philippines is going down, but they're relatively flat lines. But they're also doing very well on this part of the world. This is the Ring of Fire part of the world. So they have a lot of that. The U.S. is going up. It's a relatively cheap and clean way to generate energy. Then Italy, in the past couple years, has really taken off on this concept, as opposed to some other countries. The trend has been severe. So the geothermal heat pump system, this is just a website. If you're really feeling up to it, you want to learn more about the heat pump techniques and styles. We're going to talk a little bit about the styles. This is a vertical loop style, so it requires multiple wells being drilled to plumb this heat index. You get the horizontal loop, which is like lassos in the ground, the slinky loop, which looks like a giant slinky, and then the pond loop. These are just various styles of geothermal. So the heat pump overview is really relatively simplistic in nature. Let's get the other animation here. You need heat to transfer through the pipes of thickness, and then the heat to transfer to the fluid. So what basically happens is heat comes in, right? It goes through the pipes or whatever and warms the house, or the opposite, it can cool the house. So it basically works like a refrigerator and a heat pump, heat exchange all at the same time. That's pretty much all I want to say on that. Geothermal environmental impacts. Well drilling is a big thing. They're upset when people drill wells all the time because of groundwater, things like that. You need a road infrastructure. You need the equipment. Well drilling rigs are like a giant 18-wheeler that normally run on diesel. They're noisy. They are definitely noisy for the time you're drilling the wells. And then both carbon dioxide and methane are normally released from these wells, vented into the atmosphere. This happens whenever you drill a hole in the ground. You most always hit something with carbon dioxide and methane if there's any carbon whatsoever in the ground. Environmental impacts of geothermal. You do get noxious gas, carbon dioxide, hydrogen sulfide, H2S, which can make you really dizzy really quick. Methane, we talked about. Ammonia. There is potential for air emissions, dissolve toxic elements, definitely mercury, arsenic, boron, antimony. These are present when you drill into your groundwater aquifer to tap this resource. Land subsidence and instability. When you're taking this energy out of the system, there is potential for consequences. You slow reaction rates. You're changing the mechanism that the land is used to. You're creating flow paths and things like that. So if you increase the pore pressure in the ground, you can have land subsidence, earthquakes, things like that. And then subsurface thermal patterns. Is this really a problem? No one really knows. There are some papers published on this, but it's up for debate as of right now. So these are all video links if you want to. These are posted on the Scholar site, lectures, so you can actually click them. This is a YouTube video, so of course you can't click them. But I think that is it. Hopefully this is less painful than me coming to class to listening to me lecture on and fall asleep at 8 in the morning. But I hope everyone has a fun snow day. I will see you on Thursday. I won't see you on this Thursday, probably next Thursday.